In this video, I'll concentrate on identities, contradictions, and conditional equations. Let's start with some English. If I say January has 31 days, that's always true. This would be an example of an identity. If I said February has 31 days, this would always be false. And so this is what we call a contradiction. If I say this month has 31 days, I have something that's sometimes true. It's a conditional sentence. If this month is January, it's a true sentence. If this month is February, it's false. We use the same kind of vocabulary for equations. This equation is always true regardless of the value we select for x. This is known as an identity, and it's true for every real number. Our solution has to say that, and so in English we write all real numbers. That implies any number you select would make the original equation true. On the other hand, this equation is always false. This is a contradiction. It's false for every real number. Make sure if you run into a contradiction that you actually write down there is no solution. This equation is sometimes true. It's a conditional equation. It's true for some real numbers, but not for others. We collect the solutions in a solution set. In this case, the set with 2 as an element. Now, if I was asked to solve this equation and include an answer, the first thing I would do is distribute on the right, collect like terms on the right, and hopefully at this point notice that the expression on the left and the right are exactly the same. But say I didn't notice that. My next step would be to get a single variable term by subtracting 2a. Now notice the variable terms are gone. I have no variable left. This is a characteristic of either an identity or contradiction. To decide which you have, look at what's remaining. If it's true, you have an identity. This is an identity. 1 and 1 are the same. Even if I continued by subtracting 1 from both sides, I would still get an identity. I have to make sure, though, to include a solution, which in this case would be all real numbers. On the other hand, say I started with this equation. After distributing on the right and collecting like terms, I end up with a false equation. If I didn't notice it's a contradiction and decided again to subtract 2a, I would end up with no variables. So again, identities and contradictions both end up having no variable. And then what you're left with is either true or false. In this case, false. This is a contradiction. I have to make sure I write no solution. Here's one for you to try. Make sure you include an answer. On the right, I'd have to first distribute and then collect like terms. Next, I would try to get a single variable term by subtracting 2m. But when I do that, I notice that I have no variable terms left. Since my equation's true, -3 and -3 are equal, I have an identity, but I need to make sure to write the solution all real numbers. Try this one. After distributing on the right and collecting like terms, I would subtract 4x in an attempt to get a single variable term. I end with an equation which is false. This is a contradiction, but I need to say that there is no solution. Here's another. After distributing on both sides and collecting like terms, I would subtract 10t from both expressions and find that my remaining equation is false. This is again a contradiction, so I need to write no solution. And here's the last one. After following the procedure when denominators aren't a 1, I find that after collecting like terms, I have an identity. Therefore, I need to write down all real numbers. Well, that concludes our work with identities, contradictions, and conditional equations.